So now we take an additional step and we say, since it's so nice, let's assume that there really is something in nature that corresponds to this combination, space-time. That there really is this physical aspect of the universe, that space-time, a combination of space and time. And what it means is that we have this law. All right? In order to make that a little bit more mathematical, a straight line in ordinary space, right, is very intuitive to us. We know what that is and we know how to define it and so on. A straight line in a space-time diagram is a little bit more abstract. It's not a line in actual physical space. Of course, we draw it in physical space on a diagram, but the diagram represents something different than regular physical space. It's space-time, so it's a little bit more abstract. Now, straightness, we have an intuitive notion of what it would mean to be straight in this space-time diagram, and therefore, if we say that the universe has space-time, space and time combined in some way, we can imagine that it has this geometric structure that allows there to be straightness in space-time. It's not completely obvious, right? We have straightness in space, but we say there could be, as we see, straightness in space-time, and what it is inertia. And if we want to recognize that it's a little bit more abstract than just ordinary, a flat piece of just anywhere in space, a straight line. So we call it a geodesic. That's the technical term for a straight line. Even the straight line that we ordinarily draw along a flat piece of paper is a geodesic. It's a geodesic of that flat piece of paper. Okay, so we have inertial lines in this diagram are geodesics of space-time. And we'll also now give a terminology. If we have space-time, then a line in that space-time, any line in that space-time will be called a world line. Historically, a world line meaning it's the history forever of any particle, and you can draw all the particles, so it's like the history of the world, so to speak, with all the time in it. So it's a world line. A world line is simply one of those lines. It represents where a particle was when. So now we have a very nice phrasing of the law of inertia. Inertial particles have geodesic world lines. That's a really nice, concise summary of everything that we said. Inertial world lines are geodesics of spacetime. Okay, and that encapsulates everything, all the different things that we spoke about. And so we really believe now that there's a combination of space and time that is real, because we're going to require some kind of physical specification that inertial particles should have geodesic world lines, geodesics of spacetime.